All right, this is our last factoring of this section, E. So that means we've done 5 different factoring type of problems, correct? So this will be our 5th. All right, and we just factored trinomials. Uh-oh, I forgot to change this. Let's change this. Yeah, it's recording. All right, so we just factored trinomials. Trinomials. And, well, actually, before we did the grouping, we did this trinomial thing. Do you remember that? So, for instance, x squared plus 7x plus 10, let's say. All right, if I was asking you to factor this, you wouldn't do it by grouping, right? You would just factor it straight up. And what do? You find out what multiplies to be 10. Guys, stop. What multiplies to be 10 and adds up to be 7. It couldn't get much easier than this one. What would you do? Put the x's here. It's a plus what? 5 and a plus 2. Do you agree? All right. But here's the key to this. And I didn't even really mention this, but the title of that worksheet said factoring trinomials where a is equal to 1. What in the world does that mean, a is equal to 1? Well, here's how you would write a general trinomial. Okay, if you had a trinomial like this, you put an a next to the x squared, a b next to the x, and a c for the number that's by itself. All right, so what is the a right here? In this problem right here, what is the a? No, it's the a is next to the x squared. It's not the x squared, it's next to it, right? If there's nothing here, what is it? It's a 1. So right now, we factored trinomials where the coefficient, listen to my words, Kylie, getting all this? Where the coefficient of the x squared is a 1. All right, that's what it means a is equal to 1. Those are pretty straightforward, okay? We did those. We didn't have too much of a problem with those too much, I don't think. Those were fairly simple. But guess what we're going to do today? We are going to do trinomials where a is not equal to 1. All right? Yeah, let's go. It's a little bit tougher, but I have a little formula, I guess, if you want to call it a formula. It's a method, okay, a method of doing these things, all right? So we'll do 1 or 2 of these, and hopefully you'll figure it out. So here's example 17. This example is in the book, and it says factor completely. I'm not going to write that down. I'll just write what the problem says. All right, here we go. There's your trinomial. Why is this different than what we did earlier with those trinomials? Because what? What's true about the a? Nobody here today? It's not equal to 1. That's right. Okay, do you see that? It's a 2. That's not a 1. So we got to figure out a way to do this. Now you could, I taught this for a lot of years, and you could do it now if you want. You could just guess to see what's going to go in there. So you could put 2 sets of parentheses and do it's kind of like backwards FOIL method. All right, so this times this has to be 2x squared. Okay, remember first, outside, inside, last, right? So the first has to multiply to be 2x squared. Well, that's really not that hard. There's really not many options at all for this. So what times what is going to give you 2x squared? Yeah, 2x and an x. Do you agree? All right. Now remember on FOIL method, let's go to the last. The last 2 things, this one and this one, have to multiply to be what in this situation? To be 3. That's right. Again, there's not many options with that, is there? There's 3 times 1, and that's it. Well, 1 times 3. Now that could make a difference though, okay? Whether you put the 1 first or the 3 first. Okay, so let's do this. Let's just say we said 1 and 3. So if I put a plus 1 and a plus 3 right here, don't write that down because that's not right, okay? Don't write this part down. I'm going to change it, okay? But I'm just going to show you. 1 times 3 is 3, correct? But what has to happen to the outside and the inside? The outside and the inside have to do what? They have to do something to become a 5x. What do they have to do? They got to add up, okay? They got to add up to be a 5x. So let's try it. Let's try the outside and let's try the inside. Do they add up to be 5x? No, because the outside is going to give you what? 6x, right? What's the inside going to give you? A 1x. What's 6x plus 1x? 7x. Is this a 7? No, it's not. So is this the correct factoring? No, it's not. So what do? We try again. Try another combination. Instead of 1 and 3, let's try 3 and 1, and let's see if that's any different. We know the first is going to be 2x squared. We know the last is going to be positive 3. It's that inside term that we got to figure out, okay? So how do we do that? We take the outside and the inside, we add them up, and it should come out to 5, or 5x, if we did it right. So let's try it. 2x times 1 is 2x plus 3x. What's 2x plus 3x? 5x. Is this factored properly then? Yes, it is. Now, you could do that, and that would be okay. That's your answer, okay, without these little line thingies here. Okay, let's get rid of those and get rid of this. Okay, that would be your answer right there. Let's circle it. So you might be able to just do it in your head, but you're not always going to be able to. Sometimes they're going to be a lot more difficult, and they're going to give you all kinds of options. I mean, think about it. 2x times x, that was really the only option we had to get 2x squared. What about 3? The only thing that multiplies by 3, or to get 3, as far as whole numbers are concerned, is what? Positive 3 and positive 1, correct? Now, you could go negative 3 and negative 1, but I don't have a negative here, so I'm not going to use negative at all. So 3 and 1 is my only option. But it depends on what order you put them in, too. You know, I purposely put them in the wrong order just to show you it didn't work when it was 1 and 3. All right, so then I put it in as 3 and 1, and you can see that it did work. We're good. So you could do that if you wanted to, but there are some problems. There are some factoring problems that are way more complicated. So I want to show you a method on this easy one that's going to really help us out on one that's more difficult, okay? And you may look at what I'm going to do right now and say, you know, Mr. Hamrick, that's way more complicated than just guessing, okay? What I did before was just guess and check, all right? All I did was just say, okay, what's equal to 2x squared? Well, 2x times x is. What's equal to 3? 3 times 1 is. Let's stick them in, see if it works. Okay? I'm not completely guessing, all right? It's an educated guess, but I'm just throwing numbers in there and see if it works. But there's a better way, all right? And that's what I'm going to show you right now. You remember that ax squared plus bx thing? Okay, let's write the a, b, and c here. A, b, and c. So here's what we're going to do first. Everybody now you can write this down, okay? Now you can write this stuff down. So what I want to do is I want to take AC, see what it's equal to, and then I want to take a plus c and see what that's equal to. So let's do it. So what is a times c? This is a times c. What's the a in this situation? It's 2. It's just 2. It's not the x. Okay, the a is just the number in front of the x squared. So the a is just a 2. What am I multiplying it by?
3.
Right, 3, which is the c. And of course, that's 6. Everybody with me so far? All right. And then we're going to take those same two numbers and we're going to do what to them? Add them up. Okay, does that sound familiar? Right, take two numbers, multiply, and the same two numbers, add them up. Yeah, that's how we did that trinomial stuff. So it has a lot to do with that. So now I'm going to take 2 plus 3, and I'm going to get what? 5. Okay? Are you with me so far? Okay, so what I want to do, let me make sure I say this correct. What I want to do is I want to find two numbers that multiply, now we already have them right here, multiply to be 6 and add up to be 5. So let's do this. Just write this down. We'll do a few of these, and you'll get the hang of it. Okay? I'm not sure that I'm explaining it the exact best way right here, but I'm just showing you how to do it. Okay? So what I'm going to do is write a 2x squared. Now, with this 5x, what I'm going to do is I'm going to rewrite it, okay, with the two numbers that multiply to be 6 and add up to be 5. What multiplies to be 6 and adds up to be 5? 2 and 3. So what I'm going to do is I'm going to rewrite this 5x as, watch, this is what's different. This is what's different. Not just 2 and 3, it's 2x because it's 5x, okay? So it's 2x plus 3x. Would you agree that this is the same as this so far? Yeah. But the way that we got the 2 and the 3 is by doing this stuff right here. All right? We'll show you another example. It'll make more sense. And then plus 3. Now look at it. We just finished going over a worksheet that was factor by what? When you had 4 things, by grouping. Look, we got 4 things right here, don't we? So now we can put into action what we just finished learning about grouping. You see why I did the grouping thing first? Then they did this? So now let's take a look at this. I'm going to rewrite this whole thing. Now we can group them. Look, I can group these 2 together, and I can group these 2 together. You see that? Now let's do this. Is there anything in common with just this first parentheses? With the first parentheses, there's nothing in common? Sure there are. You got a 2 in both, right? In this first parentheses, is there something in common with both of these terms? Yeah, there's a 2 and there's an x. So there's a 2x. Let's factor that out. If I factor a 2x out from this, 2 divided by 2 is 1. X squared divided by x is x. X squared divided by x is not 1. Okay, it's 1x. It's a huge difference. Okay, plus, because of this plus right here. And now let's factor out a 2x from 2x. 2x divided by 2x, now Gage, you can tell me. What's 2x divided by 2x? It is a 1. So now you can put a 1 there. And then now, no, nothing cancels out. We're not dividing. Well, oh, I see what you're saying. Yeah, because you're going 2x divided by 2x, right? That goes once. 1 over 1 is just 1. Okay, that's why the 1 right there. Yep. Plus, now, what's in common? Look at the second parentheses. And you see what's in common with both of these? 3. So we factor out a 3. Now, if we factor out a 3 from this parentheses, what's left over? It's 3x divided by 3. Again, it's 3x divided by 3, so it's just an x, or 1x, plus what? 3 divided by 3 is 1. Now, this is a long way to go to get to the same answer that we got earlier, but there are going to be some problems where you're not just going to be able to guess and check. Everybody hear me on that? So you're going to have to go through this method. So I want to show you this method on an easier problem, because when you get to the harder ones, you're going to have to know how to do this. Okay? So now, this is just all grouping stuff that we did before. This is nothing new. The only thing new on this problem was turning that 5x into a 2x plus 3x. That's the only thing new. All right? Everything else we've done before. So now let's factor out an x plus 1. All right? If we take an x plus 1 out of this thing, we're left with a 2x. If we factor out an x plus 1 from this, we're left with a 3. Isn't that the same exact thing that we got before when we just guessed? Yeah. We just wrote it in a different order. Okay, if you want to put the 2x plus 3 first and the x plus 1 second, that's exactly what we got before. And we just kind of guessed before because these were easy numbers. Because 3, the only thing that multiplies to be 3 is 3 and 1, right? So you didn't have many choices. Okay? 2x squared. What times what is 2? Well, the only thing is a 2 times a 1. What's equal to x squared? X times x, right? So really, there weren't that many choices to guess with right here. So if I was to do this on a quiz or a test, I'd probably look at this and I'd probably just put my 2 parentheses and say, what times what is 2x squared? Well, 2x times x is. What times what is 3? Well, 3 and 1. They're both positive. I just check to see if it works. Do the FOIL method. 2x squared, that works. The 3 times 1 is 3, that works. The outside is 2x, the inside is 3x. It adds up to 5x. Yeah, that works. I'm good. You could do that. But what did I say about 4 times already today? You're going to encounter problems that you're not going to be able to just guess and check. Or if you could, you're going to be guessing 15 times and still not getting it right. Erasing it, trying something else, trying something else, trying something else. And that's a pain in the butt. All right, so this will give you the answer every single time. It looks like it's a little long, but it'll always give you the answer. Now let's do one that's a little bit more complicated. It's not a whole lot, but it's a little bit more complicated than what we just did, okay? Did you write that down? All right. Go over it again. Try it yourself when you get home, all right? Write down the problem and then try it on your own without looking at anything else and see if you can get this. If you can, then you're ready to do the homework, all right? Let's do another one. Example, I think it's 18. Again, it says factor completely. So here it is. Doesn't really look all that hard. Oops, 2x squared, sorry. This is gonna be from the book today. Then I'll give you a worksheet after this. Okay, so I'm hitting you twice on every one of these type of factorings. Okay, I'll give you stuff from the book, then I give you a worksheet because I want you to get that extra practice in order to know how to do these things. Because it's overwhelming with all the different ways you could factor stuff. So you got to make sure that you keep things straight. All right, what about this? You could, if you wanted to, just put a couple parentheses and just guess. What times what is 2x squared? 2x and an x. Now, here's the thing, though. What times what is negative 6? Well, you got a couple things. You've got negative 1 and positive 6. You've got positive 6 and... How did I do that? Wait a minute. Negative 1 and positive 6. You've got positive 1 and negative 6. You've got positive 3 and negative 2. And you've got positive 2 and negative 3. Agreed? So you have 4 different things. You might guess the first one right and then put it in here and it works. You're good to go. But you may take 4 different times guessing to see which one goes in here and not get it till your last guess. All right? So we need a better way. We need a method that works every single time. Do you agree? Yeah. And it works the first time every single time. So what do? Let's get rid of this. Remember that A, B, and C thing? This is A, this is B, this is C. What is the B, by the way? It's a negative 1, right? So what do? We take AC, and then we take A plus C. What is AC? It's 2 times negative 6, which is negative 12. And then we take the A plus C. So it's 2 plus what? Negative 6, and that equals what? Negative 4. So what we're trying to do here is we're trying to find out what multiplies Give me a sec. What did I do? A plus C. Yeah, hold on a second. I'm just working on my explanation here. I put A plus C. I'm sorry. I think when I explained that earlier, it wasn't exactly right. What I want to do is this. I'm sorry about that. When I say A plus C, I think I might have confused you. Watch what we're going to do here. What I want to do is I want to find Oh, I'm sorry. My explanation was terrible on this. What I want to do is this. You see, forget the AC thing. Well, forget the A plus C thing. All right, let's just do this. See that negative 12? And you remember it has to add up to be that middle one right there? So what I'm going to do is I'm going to take this negative 12 and I want to think of something that multiplies to be negative 12 and adds up to be negative 1. Do you see that? So what I do is I take the two n ones, I multiply them together, I get a negative 12. So I want to find out what times what is going to give me negative 12 and the same two numbers have to add up to be a negative 1. Are you going to use 12 and 1? Is there any way you can get 12 and 1 to add up to be a negative 1? Are you going to use 6 and 2? No. What can you use? Right, 3 and 4. Or negative 4 times what? Positive 3. Why do we use that? Because negative 4 times negative 3 is negative 12, and negative 4 plus 3 is what? Negative 1. Let me do the next step and we'll quit. Okay, I'll let you go. So watch what we do. Instead of writing negative 1x, what are we going to write? We're going to write negative 4x and 3x. Do you see that? Negative 4x plus 3x. And then the last term, I just throw it down. The only thing we did was take this and made it into that. Now, you should be able to do the rest of it, correct? What are we going to do? We're going to group it. We're going to factor by grouping. And then you're going to come out with this when you're finished. 2x plus 3. Okay, so that's what it's going to actually come out to be. All right, you try that on your own. Here's your homework. You're doing page 56, and you're doing 51 to 67, just the odds. Okay, there it is, right there.